Hi, I'm Sean Armstrong. I used to be a high school science teacher. I got trained up at the university at CCAT, this demonstration house, where I also met my partner, Michael Winkler, here. This is an example of one of our cool zero energy projects. Look, Shane. Shane is the developer of my all-time favorite that I always put on my intro slide. It says 9-story tall PV wall on there. It's affordable housing for low-income seniors. It's a passive house. It's right on the DC Beltway. And this is my little house here. Okay. I think that I accidentally put a funny, can you go back a few slides for me? That was it, okay, here we go. So I'm giving a presentation on what's missing, the things that we don't have yet from a technical perspective. And this matters because we are delaying electrification to some degree for not having things. And I realize only Mohammed here is at the Energy Commission with a great amount of grant funding at his disposal, right? Yeah. But these are the kinds of things that remain to be funded by California, NYSERDA, by other organizations that have some money. So one of them is an easy to install portable. This is a portable, so you roll around with this thing. It's got a little attachment on it, and it sticks into a window, either vertically or horizontally. Same thing with the window air conditioner. These represent 6 to 8 million purchases a year, whereas the heat pumps that go into people's homes that are bigger are 4 million a year. So this is the market in the United States for heat pumps, and yet none of them come with an inverter, with cold climate treatment so they can melt ice off, de-icing. And this, like if you go into New York City, you see these are in mansions. These are in every brownstone, and they're noisy, they're really inefficient. We can make big strides if we had those two form factors developed to be cold climate heat pumps in terms of being able to do rapid, cheap heat pumps. Notice that these things are usually $700, and where it's literally $7,000 to install the same 12,000 BTUs of capacity, but doing it with a cement pad, a heat pump on it, a refrigerant line, a fan coil, like that same ton, 12,000 BTUs of heating and cooling, is an exponentially 10 times more expensive if you don't have it already factory finished and easy for a human being to install themselves. So, same situation, but this form factor, the hotel type. Okay, so Innova, one of our beloved manufacturers out there, so this is sort of a spec that Yehuda had come up with, saying, hey, we know we need a high COP, a coefficient of performance, it's the efficiency, at -5 Fahrenheit. He's putting in ERVs into his heat pumps, these little packaged heat pumps. So an ERV, reclaiming heat and air conditioning at 1/13 of the energy of a heat pump and 1/37 of electric resistance. See, right now these things have electric resistance for space heating in the wintertime. So just radically different amounts of energy. They're very leaky is one of the problems they come with. So they leak about 40% of the air that they heat and cool around them through the system itself. So we want MERV 13 for smoke season. We want low global warming potential. R32 is being used more and more commonly. It has 1/3 the global warming potential. Self-cleaning coils, which is something LG is the first ones to do, where they will ice up their coil and then melt the coil, and so it washes off dust. The ultra-quiet, 10-year warranty, like most of them are in the 45 to 55 decibels. 27 is like super library quiet, and they can make them. That little to no leakage, so important that we don't have all this leakage around the envelope, and getting them 4 inches off the wall so you don't hit them with your shin. Now, what this will do, if we address the fact that this is the vast majority, like 60, 70% of the heat pump market is those things I just showed you in the United States, the air conditioner and heat pump market. So SMUD has put in thousands now. They've got 700 in this study. And what they're showing here in gray, sorry, in orange, this is the old peak in the summertime, in the evening. This is the winter peak. Now that's after, this is the post-heat pump retrofit summer peak. So the summer peak was here, now it goes down to here, because they put in air conditioners with inverters, which are a computer. Once they did that, going from single speed to any speed, because the computer allows the heat pump to operate at any speed, they dropped the peak. Now it created a winter peak, because now they're doing space heating with a heat pump and not gas. But the winter peak is smaller than the old summer peak and is smaller even than the air conditioning peak now in the summer, telling us that our grid is currently designed for electrification if we use computer-based heat pumps. we are not going to create this new disastrous winter peak, which I hear at building science conferences is the reason not to electrify for space heating. No, our grid is actually designed for that peak, and we're going to go down to that peak if we get the computers in there. So Sean Oram, who is our hero here for central heat pump water heaters, if you have any questions, the man. I've been fanboying Sean since 2016 when I saw him at the Hot Water Forum. So large CO2 boilers for big buildings. Okay, we don't have enough of these. The link has shown up. This is an upstate New York manufacturing. It's a reprint of a European product. It's a CO2 boiler. Carbon dioxide boilers means that you can get up to 185 degrees Fahrenheit. All the other refrigerants, R30, 410A and 132A, the other two fossil fuel-based refrigerants, they get to 130 to 140. And radiators and the fan coils that are like, baseboards, those are designed for 160 to 180. And you can't get there from here with most of the existing heat pumps unless you use electric resistance as a booster. These go to 185. So you can slip them into all these existing buildings without it being a humongous hassle. So this is Flowtech. They're just coming out. John Hellard, Sean's partner up at Ecotope, is helping us try to bring that to market with a CalNext grant. That might happen or not. CalNext has a lot of money, but they only give it to themselves. All the people who got it are like, that's our projects we're going to do. And you're like, but we have all these brilliant ideas. Okay, so an American-sized CO2 heat pump water heater, because the ones that we have right now are invented in Japan for a 150-gallon bathtub. First, you take a shower. Every family member takes a shower. Then it's a big bathtub, and it has to all be filled. And so 150 gallons of hot water is not what these American-style tanks are for. They only store 40 to 80 gallons. They only have a recovery rate of hours, basically, if you empty the whole thing. But if you had CO2, you could raise the temperature of the water up to 180, but only release it at 120. So you could have vastly more storage if it was just using the CO2 compressor. And you'd have greater efficiency. These operate at a COP of like 2.5 to 3.5. Coefficient of performance, 1 unit of energy in, 3 units approximately that gets gathered from the environment. But if you're doing a CO2, you get a COP of 4, 5, or 6. So dramatically less energy. And water heaters use 40% of the energy in a house. So these are big moves that you're making. And also, it has to be 120 volt and less than 900 watts. So these can get plugged into anywhere, retrofit ready, so any outlets can take them. And this doesn't exist. This badly needs to exist. These also don't exist. These are real products. This is a lowboy. And you see this often in like the South, American South. You'll see them in apartment complexes, lowboys underneath the sink or something like that in a closet. Electric resistance. This is a tall tank, that's what they're called, and they're skinny. They're like 16 inches wide instead of 22, but they go up. And this is a 40-gallon tank. This is a 30-gallon tank. These don't exist. With our heat pump water heaters at 21.5 or more, you can't fit them into a 16-inch closet because they're often built exactly that. We had a project down in San Diego that we had to put electric resistance tanks in order to electrify it because the closets were too small. This is Japanese, and it's a really interesting strategy. This is a 40-gallon tank hung on the wall to get you scale. That's one of these big bathtubs down there. So it's kind of big on the wall above you. And they store them, and they'll do 20-gallon tanks, 30 gallons, and 40 gallons. And they'll store the water at 180 to 190 degrees Fahrenheit and then release it at 120. So they get essentially double or more the volumetric storage that you might think. Oh, that's a 40-gallon tank, gets me a certain number of showers. They'll get twice as many out of it. And they'll put 20-gallon tanks above toilets horizontally mounted on the wall. So it saves space for tiny houses and apartments. And we need a heat pump version of that. Yes, you would have the heat pump operating in the bathroom, sucking the heat out of the bathroom. That'd be great. It'd dehumidify the bathroom. The bathroom is often a warmer place because it has showers going on in it, except that you'd walk into a cold, dry bathroom. So we need it for some people in some situations. Not everyone has the same thing. Pardon me. Okay, so we need more warranted EVs for bidirectional charging. This is Nissan's warranty. Thank you, Jesse. Is back in the kitchen. So She went through the Nissan warranty. It says charging, discharging, using quick charge port is possible, even several times a day. This is bi-directional charging, where you take the car battery and you dump the energy into something. And Nissan has been warranting this since the tsunami in 2011. And that tsunami, it essentially took out 30% of the power supply in Japan overnight. All nuclear power plants were shut down. And Nissan, being very kind about it, they said, we'll let you start charging your house in the evening during the grid maximum, like 5 to 8 p.m., with your car. And people started doing it. It got deployed then, and this is in Hawaii, Maui, coincidentally. I wish right now that they'd really done it, because the city of Lahaina, right? I think I'm just, bleh. The city of Lahaina, if people had like an F-150 or a Nissan, they could be occupying their homes that didn't burn down. 10% are still there. They can't occupy any of them. The grid isn't back. And this is something like a day in and day out. I think it would be great if people could use their vehicle, go drive to a nearby town, charge up, come home, and have enough electricity for 3 or 4 days, like that. So this is LA's Air Force Base in 2014. And we're saying we need more cars that are willing to do this. And they're saying 25, 2026. We need them as soon as possible. So VW, GM, Ford, BMW, Volvo, all of them have promised this, but only Nissan Leaf is delivered. The Ford Lightning is not the same thing as what I just showed you with the Nissan Leaf. The Ford Lightning is a grid-forming vehicle, meaning it makes its own off-grid experience. It does not pay attention to the Hertz sine wave that's going through the grid. It is not grid following. The Nissan Leaf I just showed you are grid following. You can plug it into the grid and get rid of like a spike on the grid in the evening in the summertime. Grid following. Grid forming is this little box here that the Ford F-150 is plugged into, and it is powering the house, and this guy's got a chainsaw and an extension cord going back to it. And so they have 11 120-volt ports on them, plugs. You can stick things in, chainsaws and all the rest of it. And they have the ability to power a house off-grid. That's cool. Nissan can do that too, but it is a grid-following strategy that it's doing. It makes a grid, but it is trying to pay attention to the grid around it. Ford hasn't made one that pays attention to the grid. Why is this important? Okay, so all of the Tesla Powerwalls installed in California are that amount. This is what the utilities have managed to install so far on the grid. This is what people are driving around in California as of June 2023. This yellow bar represents the 80 miles of reserve that people who participate in vehicle-to-grid studies say, I would like you to take as much as you want, up to 80 miles. I want to wake up in the morning and be able to drive 80 miles. So that's 80 miles of reserve power, and this is still double what we have in the utility grids. And vehicles are selling way faster than the grid is putting in batteries. The residential market is not really a market. This is a joke compared to this. And so the pricing per kilowatt hour is half than it is in residential. So if you're getting a Tesla Powerwall and you're paying $1,300 a kilowatt hour, you can buy a car for $500 a kilowatt hour and plug it in. And you got a huge battery that you can go drive someplace else to recharge if you got an issue. PG&E has been testing the Ford F-150 Lightning with their collar. You own this collar. The utility owns this meter. On this whole situation, only this thing is owned by the utility. You own and paid for all those things, and you can put in a collar on the thing that you own behind the utilities meter, and that collar can take like 80 amps. It can take about, let me put it differently, it can take about 60 to 70% of the power that's delivered to that building. It can charge back in or pull out. Usually, you can only take like 16% out of a circuit breaker of your total electricity. This is because you're plugging straight into the service, not into your breaker panel, which has all these fire prevention devices in it that limit the amount of power you can take out of it. This thing is a fire hose. So the Ford F-150 can plug into a meter collar that PG&E is giving away free to people who've had power outages. And this collar also exists now for plugging in solar arrays. Usually at your 100 amp panel that most people's homes have, you can only put in 16 amps total. You're smiling? Yeah, I thought you were giving me like, get off the stage. No. Yeah, so you can get one of these collars and you can plug in up to a 15 kW solar array. If you didn't have that collar, you could plug in a 4 kW solar array into your 100 amp panel. But if you don't use the panel in the house, go straight to the wire to your house, the service. That allows you to plug in and pull from a lot more electricity. So those collars, simple utility meter collar for connecting vehicle to building or connecting solar arrays. These solar collars are a way to get around the panel impediment. Retrofit-ready stoves. In Japan, which is the center of electrification, Japan and Norway, not America. In Japan, you see these 3-burner induction ranges with a pull-out oven. So this is, they do grilled fish. America, we do a turkey. Our oven is designed around a turkey. There's nothing else that we do with our oven that we design for other than turkeys. So they don't do turkeys. And so they have pull-out ovens. You can do your mochi, you can do your fish, all the good stuff. Now, we need that. We need a 120 volts, 1800 watt, which means you can plug it into the kitchen circuits, 3 burners in an oven. Our organization, many of us have done tons of testing for years to figure out what can 1800 watts do. It can do 3 burners and an oven at the same time. Just barely, but you can do it. If you're like, everything's efficient, everything's working, and most people don't cook on 3. It's interesting to see that in Japan, they usually only sell 2-burner and 3-burner stoves, and you can't really buy a 4-burner. Have you ever tried to cook 4 things at once? That's like Julia Child level stuff, you know. We need more battery backup induction stoves. So this is an example of an 1800 watt, 120 volt stove with 4 burners and an oven, but it has a 4 kWh battery in here. That's 1/3 of a Tesla Powerwall. So this is a $6,000 stove, which is basically a $4,000 battery with a $2,000 stove sitting on it. This is also got a battery, but it is not a big battery. It's a 3 kilowatt hour battery. This is a 4. And this doesn't have an oven. This one has a 120 volt plug that you can plug other things into. Charge your cell phone, charge your, Kate, you've seen Copper Channing do their thing? Because you're neighbors. So what do you think of it? You've seen it in person.
It's fantastic. They don't make ones that are big enough for single family homes. We put them in many of my constituents. So it's great for
right.
If they're like, I want a bigger thing.
So this like 32 inch, they're asking for the 40 inchers and the 40.
We're waiting.
Yeah, it's only 4 burners. I live on 2 burners. So this, by the way, Weldon Channing would like to be here to give his own presentation on Channing Copper, and he got COVID at RE+. And so just encourage everyone who wants to wear a mask, go right ahead. We're trying to keep the door open. We've got an air filter there and an air filter there. We're trying. So we need more of these. But to your point, Kate, this is not a great fit for an apartment because any battery in an apartment, any battery is a small fire hazard. And when you have multiple people living next to each other, your fire hazard becomes everyone's fire hazard. And so the tragedies that keep on happening in Brooklyn, particularly with electric scooters being charged in people's apartments and then killing lots of people, is like every few months you can read about that. And so the New York Fire Authority, New York City Fire Department folks, they've said, no, we don't want a battery as a part of our retrofit strategy for New York City. We don't want battery-based stoves, even though this would work great, other than being crazy expensive. The one I showed you previously, we need an efficiency-based stove without a battery. We just need to dive deep into efficiency so we don't have to store energy inside apartments. We need a big walk. Some of you guys, I think Berkeley, right, you got sued. We all go, God damn it. And it's the American Restaurant Association, and their only real leg to stand on was that the American and Pacific Islander chefs, the API chefs, didn't have a big wok. Of all the things they could say, that was the only thing that was true. That we have tandoor ovens. If you're a Pakistani and want to cook like roti on the side, we have all these amazing kinds of electric devices, and we don't have a big wok. So David Suhu, who was one of the prominent voices against the electrification ordinance in Sacramento, I partnered up with him. He's friends with Jonathan, so we actually had like a family relationship of sorts, because he was pissed at the idea of banning gas on behalf of his API fellow chefs. And so I got him on the phone with him, And he explained to me the thing is that we have only 11-inch induction coils available in the United States. Induction only heats directly above it, and it doesn't really spread. So when you're cooking on a wok, right now you can see like Microsoft has Jade as the company. They're all over LinkedIn with their cool woks, but they're only really 14-inch woks with a 10 or 11-inch coil underneath it, and that's for one dish. And they, in China, I kid you not, make woks that are bigger than I can do this. They make 72-inch wide woks, and I have like this is about 70, 72 inches here. So you need like a tall person to really push these woks in the big gas flames. Like that's how they do it, to make gigantic volumes of food all at once. We're not trying to go that far. But we got a hold through LinkedIn of a Chinese manufacturer, and Iris was saying, oh yeah, 18 inches, that's no problem. And she worked it out. And I have one in customs. I was hoping to have it literally delivered here on the deck so we could see this new 24-inch wide, 18-inch coil wok. And it wouldn't be able to plug in because it has to be like 230 volt and things. It was just going to be a piece of metal. But instead, it's in customs, and you won't get to see it. We tried so hard. So I'm thinking we'll put it into like the Oriental Buffet here in town, which is our biggest restaurant that serves API food. Okay, so what I just found out a week ago, which blew my mind, is I thought 18 inches is something that we have to build for us. It's like, oh, I found this cool custom company. They talked to the engineers. They're making us this thing. And it was only through LinkedIn chat a couple days ago that I got clarity with Iris, and she's like, oh no, they make them much bigger in Japan. I mean, in China. In China, they're like 20 inches, 24 inches. You just wanted an 18-inch. It's like, well, I mean, yeah, I did, but I thought that was the limit. It's like, no, we make really big ones. So they just don't exist in the United States yet. And this is a political issue, which is why we put some money behind it. It was to try to make sure that this product does exist in the United States. Defensively, it is just a boat ride away. And that's it. That's my presentation. So, have you any questions about this missing products presentation that I gave? Okay. Yes, Claire.
Thanks. So you talked about a number of pieces that are missing.
Yes.
I think, and the walk piece, you spoke of how to close that.
Yes.
Do you have thoughts on any of the other ones?
Yeah. Could you bring up my slides again and take them back to the beginning? Okay, so of the things that you and we could contribute to, there was a venture capital organization down in the Bay Area that said, oh, we're going to put $1 million behind this, and they never did. But basically, it takes $1 million. This takes $1 million, and this takes $1 million. Having talked with manufacturers, they said, if you give me, not a loan, if you give me $1 million, a year later, I will have this for sale. But I'm not going to take the risk on retooling and getting certified, all of which costs $1 million. I'm not going to take the risk. You do it. You know, if you're so convinced this is an important thing. They're all like that. It's not that they wouldn't do it. It's just that it takes $1 million. And so the Energy Commission gives out $120 to $140 million a year, waiting for 1 million of it to come drip in this way. Or 3, because there's 3 products I'm showing you here. So that is one of the things, is we need a supportive HVAC manufacturer and $1 million. These are coming into market, and they are more than $1 million of investment to get into them, but more being like 3. We're trying to pull together a new heat pump manufacturer, a new heat pump, CO2 heat pump, and it's going to take about $3 million, 2 to 3. So it's not that much, once again, with like these $100 million increments that are flowing. And this is our block. So I'm money. That's the answer, is that we need some targeted grants towards specific products like this. Yes, Avery.
The collar, how does that fit in with demand response and peaking events?
The collar.
And then who owns it? Is it that's the coupling.
Yeah,
So,
you own it. So the answer is you
but
personally own that.
Can the utilities get credit for that as far as storage that they could pull out for demand response?
So the collar for
infrastructure
now.
or things like that, because it's right there.
Yeah,
So it's just the coupling,
yeah.
right? But it seems like it's the homeowner side, so the utilities aren't maintaining it, so they can't claim infrastructure with it.
Well, the way PG&E is deploying it now, they're only giving it away, and you own it then. They give it to you, and it's only if you've had 2 power outages in the previous year. And they're designed for generators, gas generators. This is And there's only one ever electric vehicle that they've allowed to plug in. They're just testing it this summer. The F-150 is on the official approved list. To your question about demand response, this is designed for off-grid at the moment. The assumption is power's out, and then they like show you how to click things, and then you're allowed to plug your truck in. So it's a long distance from being a distributed energy resource.
But that enables beefier virtual power plants.
Yes?
Which utilities kind of hate anyway because it's on the customer side of the meter.
Yeah.
But that's the physical enabler.
It is a physical enabler, and this strategy is what you're pointing out. It's like this could be for a solar array. This could be for a distributed, and like there beacon controls. And that strategy of having lots of power available there so you can do big moves on the energy side. Yeah.
John, isn't that on the wrong side of the disconnect switch so it could feed power back into the grid? How do you isolate that?
Well, it is designed. This is designed for solar into the grid. So the solar version of this, the solar DIR, or Connect DIR is what the brand is called. That's just for solar. These freebies that PG&E is giving out, they are insistent that you have to shut off everything before you're allowed to feed in this way. They give you specific instructions. But you're the engineer that knows better about this than I do. But I know, having talked with them, that that's how it functions.
Yeah, that must have an ATS on the outermost edge.
Are there any other questions? I want to make sure everyone gets a turn. Yes, Michael.
Sean, could you briefly talk about the issue of CO2 heat pumps dealing with high return temperatures and how that affects this?
Okay, so Sean, do you want to take this one for me?
Let's see. So you presented CO2 stuff. CO2 is a really high lift cycle,
Yes.
and we can bring about 85-degree water back to it before it really starts to sort of fall off. And that has to do with the CO2 cycle itself, refrigeration cycle. And so, I guess going back to your question, what specifically?
Oh, well, what happens is that if you've got a tank of for a apartment system where you've got return loops, then you have to separate them too. But I'm thinking about it in these smaller things. If you're trying to keep a tank of water hot, how you can do that with CO2 heat pump, because you're taking a tank that's already close to the temperature you want, and how do you deal with the fact that CO2 has trouble dealing with anything above 85%?
Well,
I think that's a great question. I think that's going to be a limitation of trying to do a tank type. I mean, I think the physics of that cycle are going to make a tank an integrated unit, CO2, really hard to design efficiently. And I think that's why we don't have it. I think the answer is propane, just to throw out.
the refrigerant, not the burning of it.
Sorry.
Yeah.
The refrigerant, propane, is another thing I would add to your deck. There are products in Europe and Asia, and that refrigerant is really solid. We've looked at the performance of it. We just can't get it in. There's a limitation on it.
No more than
speculate.
16 ounces of propane can be used in a heat pump, and it seems to have been a bribe that UL took from the refrigerant industry in like 2017. UL went private. They're not a public nonprofit or anything like that. They just take money to do things, and they seem to have banned propane in any significant volume, even though it's used world round.
Yeah.
For safety, but they took money from the refrigerant industry to determine its safety. So
Yeah.
that's a problem.